on your own. Now I will give the introduction. This is Mark Ramm from Canonical. He's going to talk to us about the Go programming language. So take it away, Mark.
All right. So who has heard of Go? Okay. Who writes code on a regular basis? Okay.
In Go or just writes
in
code?
any language?
Oh.
Okay. We already established that nobody here does Java. What's the most common language? Who does Perl? I know there's some Perl people. Okay, a couple. Python. C. We had two. My question was why, if I can make this go. Okay, why? So I'm going to answer this question through sort of the lens of what happened at Canonical. We wrote Juju originally. It was prototyped in Python, and then it was rewritten in Go. So I'm going to talk through the thinking behind that decision rather than abstractly answer this. But please ask questions. I want this to be interactive. So who uses one of these languages normally? Who's like a dynamic language person? Okay. Who's one of these language people? So we got a couple. Who's one of these language people? There's never any of these people. I just want to say, never. I wrote some stuff in Erlang. Oh, it was a horrible, horrible experience. We'll talk about that later.
Doesn't F fit into that, or
yes, F would be another one of those. They're not exhaustive. Yeah, Microsoft's functional programming language is F, right?
Is that what it is?
I think so.
Maybe F sharp is what I call it.
I guess I will start out a little bit abstract. We had three problems: concurrency, concurrency, and concurrency. And I think that's actually pretty normal these days. C was an abstract machine language. So you have assembly. That is a concrete machine language. It's for that particular hardware. C was like, hey, we should have programs that you could write, and they could run on a variety of different hardware. So they made sort of an abstract machine, like conceptually, that you can think about, and it has threads and it has things. But really, C is very much about an abstract machine where there is an execution unit that does things in sequence. Not there are 10 execution units, got 10 CPUs. C is very much designed for a world where the abstract machine does one thing at a time. And the concrete machine underneath it did one thing at a time. And that worked for like 30 years. Like, there were multi-core machines and things happened, but they weren't common. And it was okay. Like in 1995, if you were doing video transcoding and you had 2 cores, you just had to live with the fact that it was going to use one of those 2 cores. And you were also super rich, so who cares? Like, you're not a normal person. Today, everybody has multi-core machines. Like, my phone has multiple cores. Like, and all of the languages that were on the list, except the functional languages, really were designed for single execution unit, and then threads were just a quick way to switch context, but still execute a bunch of things in order. So concurrency is hard. I forgot I had this slide. Concurrency is hard. I did a talk called Concurrency is Hard at...
Spelling is hard.
Spelling is also hard, especially if you are me. Yes. There will probably be more spelling errors later. Just, this is a
okay, that English class, so.
Everybody who gets a spelling error gets a gold star. And probably concurrency is probably spelled wrong again.
Yeah.
Wrong and different?
So I did a talk called Concurrency is Hard at Code Mash, like 3 or 4 years ago. And the night before, and the talk had this idea of like, I was gonna talk about various concurrency related problems that I have run into in my life. And how like you get some code that is highly concurrent, and then there's a problem, and you have to figure it out. And you didn't write that code, and duh. And so I had used this metaphor of being left holding the bag several times in this talk. And the night before this talk, I was going around with people and I was drinking, because that's what you do at conferences, right? But not as heavily as some other people that I was with. And this one guy was really, like, he was drinking a lot and he was hitting on this girl. And he was drinking a lot and hitting on the girl, and drinking a lot and hitting on the girl. And then we run out of at the place we were at, the room party we were at, they ran out of things to mix the rum with, so he's just like, hey, pour me a glass of rum. And I was like, that seems like a bad idea. I'm not involved in this. He's like, no, you have to decide how much I'm drinking. And I'm like, then I decide 0. And he's like, well, give me a little bit. So I'm pouring a little bit and it goes rum. And then he's got a good, inch of rum in the bottom of his glass. And I think the girl, who will remain nameless, but is named after a Mattel toy. It's really nameless. She's Optimus Prime, by the way. No, that's not Mattel, that's Hasbro.
Whatever.
Anyway, so she decides that this is her cue to leave. And so she gets up to leave, and he decides that this is his cue to down the 1.5 inches of rum and follow her, because if she's leaving, he's got to go too. So he downs the rum, and this story has, anyway, it has a point. So he downs the rum, and then he jumps up to go follow her. That was not a good idea. Like, clearly, the combination of the rum and the standing up quickly did not agree with him. And so he grabs the brown paper bag that the rum was in before it came out and became substance that goes back in the brown paper bag. And he grabs the brown paper bag and refills it with rum. And then I almost said her name. She's leaving, and he decides that he needs to follow her, so he just hands me the bag.
Ew.
And so now I'm sitting there with a bag filled with someone else's vomit. And I'm like, oh, I need to get to the bathroom because this is not okay. And I'm like, make way. And everybody's like, who is this dude? This super creepy dude with a bag full of vomit.
I don't know, but he says make way, you make way.
Right, and I'm like, it's not my vomit. Like that. They're like, that's not better.
I can't wait to hear how this has to do with concurrency.
Yeah.
I'm waiting.
No, so it's just a metaphor.
That's the-
So now, if I think of left holding the bag, I have a very concrete picture of what that means.
Somebody else's mess to clean up.
Yes. And it might be oozing and gross.
Yeah.
All right, so I'm going to just talk quickly about.
We passed it.
It went
Yeah,
past one.
it's past my SQL.
Wow, that's deep.
We can do that.
Just keeps going.
Yeah. All
And
right.
now back to my SQL. Okay.
All right, so we're just going to talk about MySQL while it's little. So I worked at this company called Optio, and we had a piece of software called the MedX that printed patient medical records. It was not like rocket science, but there was some concurrency needed because you're printing to lots of different printers. You need to spool multiple things at a time. You need to, like, we print a lot of patient records. And so we had a network queue. Who knows what a network queue is? Okay. So it's just a queue of things that needed to be printed. And then we had a bunch of workers that were separate processes, multi-threaded processes, but separate processes, that pulled down stuff from the network queue and then spool them up to print. Not rocket science. That network queue was implemented with a Postgres backend, and it used select for update. It abused SQL. So select for update. Who knows the difference between select and select for update? There's one dude in the back. Explain it.
One is selected read only, the other
Mhm.
is selected for read and writing.
Right. So it locks it
Record.
until you have updated it by default. MySQL does not have select for update, so when we had to port it from Postgres to MySQL for bad reasons, because there are no good reasons, we couldn't use select for update. So MySQL has this thing that it calls opportunistic locking, which sounds great, but like I don't even know what that means. Like opportunistic locking? Well, if I can, I'll lock it. Otherwise, screw you. And it really is just a big mutex. Like you give it a string and you can ask it, is there a lock for this string? It doesn't actually lock anything in the database. It does nothing. But it'll tell you. So we constructed a string that was the query to get a specific record, and then we'd lock it. We'd grab the opportunistic lock for that string, so if somebody else tried to get that specific record, then they would fail. And this was great, and it worked fine, except like one time in 10,000, or somewhere thereabouts, we didn't know exactly, it would just print somebody's forms twice. And because we were medical records and we were obsessive, we figured we had to solve this problem. So 2 weeks of thinking hard about where everything was locked and what was happening happened. Like with me and one other guy, just brains exploding every day trying to figure it out. Until our friend Aaron was like, just put a bunch of sleep statements in there. Very good idea. So eventually we figured out a place where if we put a sleep statement, it would print twice a lot. And then that helped us figure it out. And it turns out MySQL optimistic locks are each client connection to the server has a thread. Each thread can hold one opportunistic lock at a time. If you grab a new one, it will silently release the one you just had. That's not a documented feature, by the way. That is just a feature. So that was big fun, and we eventually, but 4 weeks of people's lives were wasted trying to figure this thing out. Because concurrency is hard. We did it right. We used the thing that we had used for years and years to try and do it. All the logic was right. We just didn't know that something underneath us was not doing what we thought it was going to do. This is more Juju related specifically. Juju, who knows what twisted is in Python? Okay, Wolf, and one guy in the back. All right, so Python.
Thanks a lot.
You get to be one guy in the back, Craig. Just deal with it. If you sat in the front, you wouldn't be one guy in the back. You'd have a name.
He'd be one guy in the front.
Yeah,
I used
guy
to
in the
work
front.
with him, and I used to work with Wolf. So Twisted is a asynchronous programming library, so you don't have to use threads. You can just do everything asynchronously. The problem with Twisted and the problem with Juju is that everything gets a chain of callbacks. If any of those things in the chain mutates this return value on the way back, or mutates the call value on the way down, the things underneath it change. And just as a fact of Python, depending on what modules get imported in what order, those callbacks might get added in different orders. If you have a combination of those two things going on, your head is going to explode. And I won't go into all the details because they're boring, but they're no fun. So Python has a disclaimer. Like, I am more of a Python programmer than a Go programmer. so I have lots of Python. I have spent a lot more time in Python world than I have in the Go world. I'm a Pythonista and not a Gopher, although I think Go has a lot of advantages. So, processes are good because one of the problems with asynchronous and thread programming is that you have a mutable state that gets mutated underneath you, and you don't know when, because threads and processes, threads particularly are bad about this, is that you have 2 lines of code, something else happens sometimes in between those 2 lines of code. And you don't know what happened. The OS just decided that it was going to switch context, do some stuff, switch back. You don't know when it's happening, you don't know where in your program it happens. You don't get to decide, oh, these 5 things happen all together, and then you can do other stuff. No. You have no choices. We're just going to do stuff, and that's just the way it is. And it's very hard to reason about threads, but processes at least, you can't mutate state of anybody else. You only have what is in your memory, not anybody else's, and you have to have an explicit channel. And earlier I mentioned to use a network queue. That is a way to use an explicit channel to communicate. When you use an explicit channel, you can reason about, okay, something got put on that channel and then it got pulled off of that channel. What happened? When is it going on? Like, there is a place for you to start thinking about how did this data change and where did it change? It can only change through explicit means. Whereas if it's just some junk laying around in memory, who knows when it changes or why? I mean, you have to know all of the code to know why, and you have to know when thread switching happened to know when. So it's very complicated. It is hard to reason about. And so the MySQL example, like, it was threads internally to MySQL, but for us, we were doing multi-process. We were being explicit about everything, and it was still horrible because our network queue was broken, which was our own damn fault because we tried to port it to MySQL. So that was a little side note because I wanted to actually say concurrency is hard. Dynamic languages, they're fast and fun for programmers. Like, you can get things done.
What were the dynamic ones you said?
Python, Perl, Ruby, Visual Basic, PHP, JavaScript. There are languages in which you can say A equals something, and then A equals something else of a different type, and that's totally okay. They're dynamically typed. That's why I'm calling them dynamic. Static versus dynamic typing is not the one true method to split languages apart, but it's the method I'm using right now.
Okay, I was thinking the 2 were interpreted versus compiled.
Right, well, and that's confusing too, because a lot of interpreted languages like Python, there's a compiler. It gets compiled to an AST, which is interpreted. And C#, where do you put C#? Is it compiled or interpreted? Where do you put Java? Is it compiled or interpreted?
Pseudo-compiled.
Right, they both have compile steps. And then they have a virtual machine in which they run. And Python is just like that. Like, fundamentally, there's not a huge difference between Python and Java in terms of compilation. They both compile to an intermediate language that gets run in some sort of interpreter. Okay, so not all dynamic languages have trouble with concurrency, but Python, Ruby, JavaScript, Perl all have concurrency issues. Python is where I come from, so I can bitch about it the most. It has a global interpreter lock. The global interpreter lock locks the whole interpreter. So if you have multiple threads running, don't care, I got a lock. I'm gonna block everybody. And the Python global interpreter lock only gets used in rare cases, like when you reference or dereference an object. So hardly ever. I mean, every single line of code. threads are, in all of these cases, threads are also expensive. If you want to have 1 million open connections, if you open 1 million threads, you're going to use up a lot of memory. And then they all have, like, in spite of Twisted being nicer than just straight callbacks, there's still callback hell. Twisted did not get rid of callback hell. I can't really talk about what's wrong with concurrency in Ruby. Well, I can. Ruby has an even worse global interpreter lock than Python's. Even worse. All of them use threads. Threads suck. Python has things like greenlets, and there are things that people are trying to do. But in the zen of Python, well, I'll get to that. Okay, so dynamic languages are great for programmers, except that concurrency still sucks. So they're not great for programmers who want to do things concurrently. Statically typed languages don't have, by and large, don't have global interpreter locks. I can't think of one that would have something quite like the global interpreter lock. Java and C#. People use threads all the time. They're better. I have written a bunch of threaded code in Java and in Python, which is just a layer on top of Java, and is way better than threaded code in CPython because there's no global interpreter lock. But it's still painful, and you still have this thing that between any 2 lines of code anywhere in your program, magical things can happen that you don't know what they are. Like a variable that got passed in, it could have changed somehow. Ideally, you don't use things that are not local variables in your functions, but come on. Who has ever written a program with functions that never ever did anything except with things that were passed in? They don't touch anything else, just stuff that was passed in. Yeah, see, it's hard.
Or you talk not using global variables.
Not using global variables or module local variables or variables that are in any way that live past
The function itself.
the function's lifetime.
Are you so you're also saying not using basically class properties as well?
Class properties, right? Any kind of attribute on an object that exists before or after the function. That thing can change. It can mutate in the middle because some other function somewhere else got called by a thread and did something to it.
Yeah.
This goes back to Python because Python. I wrote or worked on a web framework called TurboGears, and TurboGears basically mapped objects to URLs and let you go into them, but those objects had to be immutable. Because if you added an attribute to one of those, a property on a class or on an object, then that could easily be being executed in 2 different threads at the same time. That change could happen between the beginning of the request and the end of the request, and you get a different value than you expected. And we went through horrible meta-class hackery machinations to prevent people from doing something that was going to shoot them in the foot. But it was painful, and they still shot themselves in the foot because they figured out ways around our meta-class hackery. Which, now you have 2 problems. You have concurrency and meta-class hackery. It was a bad idea. Functional programming, though, is great. It solves all of these problems because everything is immutable. You cannot mutate any of your data structures, ever, period. Which is conceptually, like, then things can be broken down and the language can deal with everything for you, with concurrency for you. And it's beautiful, but I tried to write, like, possibly this is the stupidest thing to write in a functional language that you could think of, but I tried to write a blackjack game from the code that would take hit or stay commands from the command line and then play hands, and it kept track of decks and did all of this. The algorithms for keeping track of the deck and figuring out what cards were played were fine. communicating with the user, so that was like 20 lines of code maybe. Just saying yes or no, I want to hit or stay, 100, 200 lines. And they were horrible and I could not understand what was going on. It took me way longer than it should have. Now, some of that is just because I'm not very smart. But some of that is because it's just hard. And it assumes sort of that the hard part of your program is manipulating a very fixed data structure. But it turns out, for a lot of programs, that is not true. Juju is a very specific example. So we talked about Juju here, but Juju will deploy services for you. So it'll deploy MySQL and a database and memcache and a bunch of things, and then configure them all to work together. So 98% of the code in Juju is all about doing things to machines. Those things are not manipulating data structures in some classically functional programming available way. They're dealing with input and output, writing config files. They're doing all of the things that functional programming languages are horrible at doing. Which turns out that is what most programs do. It's stuff that functional programs are horrible at doing. Question. I see both nodding and glazed over looks. Okay. So now I'll talk about how awesome Go is. Go does one really useful thing. It has a primitive for doing concurrency that they tell you this is what you should use. You can use threads too, they're hiding in the back, but you shouldn't use them. It has a primitive for concurrent execution and a primitive for communicating between those things.
Between threads, you're saying?
They're called Go routines.
I looked at a Go routine. It looks like another name for a function.
So I'll just skip ahead and we'll come back. So if you want a Go routine instead of a function, in terms of Go, what you have to do is type Go in front of the function. So Go list sort is going to sort that list in the background. It's going to take care of it for you. And then when it's done, that list is going to be sorted. Now, you don't know when that's going to be done. So if you look at, if you assign something to the result of Go list sort, it's not going to be there until it has sorted it. And that could take who knows how long. So you don't want to just do this and then use it. So this is a terrible example because you wouldn't do this. But it is the equivalent, sort of running something in a separate thread. It gets done in the background and you don't know when it's happening or when it's done. It is happening concurrently somewhere. The Go language spec says that coroutines are, quote, multiplexed across OS level threads by the language itself. There are two different compilers that are commonly used for Go. The C compiler from Google and GCC compiler. Advice, do not use the GCC compiler. It is missing escape analysis, so your program will grow in terms of memory use in an unbounded way. That seems bad. We use it in Juju for a few things because we needed Power 8 or something where the C compiler does not have a Power 8 architecture targeted. But we are sad about that. We're trying to make Golang better, and we're trying to make the Google Go, the C compiler, target the things that we want to use, and we're also trying to help along GCC Go a little bit as well. The point that I'm making about multiplex across OS level threads is you don't know, and you don't need to know, and you don't get to know how it handles it. In the C compiler, it handles it in one way. In the GCC compiler, I think, this may have changed actually, but at one point in the GCC compiler, it just meant it gets a thread. But they get to make this decision, and they will figure it out how to make it best in Go, and you don't get to. Because you will want, say, a specific Go routine probably to run on a specific core, preferentially, and not switch between cores because now you have memory and context things and you're having latency that you don't want. But Go handles it. The next primitive that I'm going to talk about is really, really important and also really, really easy to use. So these are channels. Channels are the way that you should communicate the results of things that happen asynchronously. They can be used for other things. They're very useful. And they're first-class. Go routines and channels are both first-class objects in Go. You can name them things, pass them around, do things with them. There are basically two kinds of channels, buffered and unbuffered. The buffered channel it's like a network queue, but it's not a network queue, it's local to your program. But it is a queue. It is a list of things in order, and you can pull things off of it. And then an unbuffered channel is a thing, when you put something on it, you can't put anything else in it until somebody takes it off. It is synchronous. So you can both synchronize things using channels and make queues of things using channels. Yes.
Your buffered channel pointers, that's a 5-foot queue?
Yes.
First out, no push pop?
Yes. So it is just a queue, and you can grab things off of it. And if you try and put more than 100 things in there, it'll yell at you. It won't yell at you, it'll panic. So that is unfun. And then, this is totally unrelated to concurrency, but actually the best thing about Go. And other people are going to disagree with me and tell me that I'm wrong, but they're not correct. It's the most boring thing in the world. Go formats your code. And it just formats it, and that is the way it has to be. That's just it. That is the one true formatting of Go code. You don't have to worry about lining up. If you have a list of things that you want this to be equal to this, you don't have to line them up, both lists. It will do it for you. It just handles it. That's the way.
Indents the code you're talking?
It will indent
Does
the
everything.
code.
So it's a beautifier.
It's a pretty print for your code. But it defines the one true way to do code. So it's easier to write because you don't have to worry about what is the right way. Am I supposed to line up both sides, or am I only supposed to line up the first side of this list of things that I want to make equal to each other? You don't have to think about it. Go format will take care of it for you. You just write it, and then you type Go format, and it fixes your shit. The good news about that is then you're not thinking about it while you're writing code. You're just writing code. And when you read code, you don't have to think, oh, well, maybe he puts the bracket on the same line, or maybe he doesn't. Where does the bracket, everything is just, it is a way, you know how to read it, it's perfect. And you can't argue. People in Python land argue about tabs versus spaces. Because you have to indent things. Do you use tabs or do you use spaces?
You use spaces and you tabs.
You use 4 spaces, that is the one true way.
Tabs.
You are incorrect. Pep8 says you are incorrect.
Yeah, you were
Python
pretty good.
has a document that says the true way to write Python code is to use 4 spaces. Except if you're at Google, in which case you use 2. It actually says that in the document.
Because Vito works at Google.
But instead of having Pep8 be just a bunch of rules that people can argue about, it is a thing that happens. And you don't get to argue, people can say, oh, I would like it if Go format did this instead of that. They can say that all they want. They have to convince somebody and get that shit landed in order for anything to change. So there's one source of truth, and it is a computer. And computers are maybe not smart, but they are consistent. So the reason I think this is really important, and this is very idiosyncratic to me, and some of you may have heard this story, but the very first thing I ever did as a professional programmer, other than write some school code for the COBOL code for the School of Dentistry when I was in high school, the first thing I did as an adult programmer, I was a network administrator. We ran this code called ErgoTool, and they deployed it for the first time to a client who had paid $10,000 for the right to use this web-based survey software. And they found out that if 2 people use this website at the same time, it's totally broken.
Yeah.
All of their data would be the same.
By the government. Right?
Yeah, it's like, do not use, no, you cannot use, it wasn't like, oh, we'll give you errors, it's just like, you'll fill out the survey and I'll save somebody else's data. We found out on Thursday that they had sent this out to 9,000 employees at Eli Lilly headquarters. And they all, well, had 4 or 5 different people's data. But there was 4 or 5 sets of responses that were all the same 9,000 times in the database. And so they called us and they said, hey, we spent $10,000 on this software, and it's pretty much the worst thing we've ever seen. And we didn't really have an answer, and it was written by these contractors from a dude who dropped out of U of M and just started a company in the 90s, and they wrote some code. And they said, show us a working version on Monday, and you don't have to give us back our $10,000. And my boss was like, we ain't got $10,000 in the bank. This is gonna be a problem for us. We're not making payroll. Plus other bad things are gonna happen. So fix this by Monday.
Small things.
So this was ASP. So it was Joy. And there was a bunch of files like savecode ASP, savecode2.asp, savecode.old.asp, savecode2.old.asp. The code was formatted just in whatever random ass way people wanted. And I was like, there are hundreds and hundreds of files of code. I don't even know which of these are actually being called by the application, because there's some crazy shit going on here. And so I was like, I need somebody who's written ASP before, because I've never even seen this stuff. So we got in consultants, and both of them came in and worked 5 or 6 hours, and were like, it would take weeks, maybe months, to figure out what the hell is going on in this code. The one thing I was able to do is write a little Python script that used the website that crawled through and filled out surveys, and run it concurrently to break everything. And it worked. I broke everything. It was awesome. And I was like, hey, I can prove that it's broken, which we already knew. But I couldn't fix it. So on Sunday, the 2 consultants the second of the 2 consultants gave up, and he's like, you can pay me more hours and I'll sit here and stare at this crappy code. But it ain't getting fixed, so you should not pay me, because you're not going to have money and your company's going to go out of business and it'll be bad shit. Which is an over-exaggeration. It just would have been rough. So I didn't know what I was doing. I didn't know anything about ASP. But I was like, man, I can't even read this. And it was savecode.asp. It was the specific file that saved survey results. So every page called that, and it saved survey results from that page. It was just a bunch of if statements. If I came from here, then save this stuff. If I came from here, save this stuff. It was a great, great program. But it was like randomly indented. It didn't make any sense. And so I just went through and fixed the indentation. And I found out that they were opening a database connection inside of a for loop and closing it outside of the for them.
Nice.
And I was like, that doesn't seem right. And it turns out there was a bug in ASP circa 2000 in which you could open them, and if there were too many and it couldn't give you a new one, it would just give you one that existed. So you would grab a database connection that somebody else was already using.
Sweet.
Joy. Concurrency is hard.
Gotta love Microsoft.
They didn't give you an error, they're just like, hey, I guess I'll give you this pointer. It's exciting. But I just fixed it, and I was like, that doesn't seem right. So I moved the close database connection to inside the for loop. So now it is for every single question in the survey, opening the database connection, saving that thing, closing it, repeat.
Performs well.
Performs well.
At least it works now.
But I ran my little Python script, and everybody got new data. Like every person. I was like, holy shit. If that code had been decently formatted, like any sane person could have picked this up in a second.
Jump right out.
But 2 people gave up on it. And me, who didn't know anything about ASP
It's 'cause
at all, figured it out
we're afraid of it.
because I reformatted.
I've
like pretty
taken
code.
programs that were poorly formatted and done the same thing.
Like, and I was just like, well, I'm gonna do something because probably not gonna have a job on Monday. Better
Wow,
try something.
what a
I don't
great
know what to do.
story.
Yeah.
In other words, the Go format command solves all kinds of problems.
And so I used to use this example as why significant white space was a great thing in Python. And it is, and I love Python for that reason. You cannot have improperly indented code in Python. It is an error. Like, if you change the indentation, it changes the meaning, because you're now out of that scope. And if you do it by mistake and it's not where it should be, Python will yell at you. But Go format does the same thing, and it gets rid of all these people bitching about tabs versus spaces and whether you want 2 spaces or 4 spaces. There's a lot of people who won't use Python just because white space is significant. Turns out in written language, they added spaces between words. This is like the most important thing in human literacy that happened since the phonetic alphabet. Was, you know, in the 10th century, we had a blob of text. It was all just words, no spaces, no punctuation.
Hard stone.
It's very hard to read. Like, I have trouble reading that. And I'm reasonably competent at reading.
Compression.
Stone tablets were
Stone
expensive.
tablet.
Right, but it turns out as soon as you put spaces between the words, people can start recognizing whole words at a time. People who could not learn to read before can learn to read now.
Yeah, but you put 1 or 2 spaces after the period.
But if you write
Another argument, right?
Oh, don't get into that. But
If you're texting or programming.
well, actually, that is a very appropriate thing to the difference between Go and Python. Python enforces significant white space is meaningful, and you must do it this way. And typewriters did the same. Go is like, hey, you're going to put a period, I'm going to make it 1 space. You can do whatever you want. I don't care. Which is nice, because I grew up, because I'm an old fart, typing on typewriters, and I had to do the 2-space thing, because that's what my typing teacher told me. And it was drilled into me, and now I do it wrong. All the time.
Consistently.
Consistently wrong. Unless I'm trying hard, in which case I do it inconsistently.
So is Go format just a tool you can use if you want to?
So it is a regular part of the compile and test phase. So it will just do it for you.
Okay.
Like, there's very little, and you should be, like, the standard of the Go community is before you check in any code anywhere, it should be Go format. Because then it gets rid of all this.
Lots of filters, everything.
Yeah, lots of, like, Go plugins for VI and Emacs. And if you have something other than VI and Emacs, it probably could do that too, but I don't know about these worlds of things other than Go. Emacs and VI. And actually, I don't know anything about Emacs.
You can play games with it.
Oh, I know that it is amazing, because my friend Rick Copeland does amazing things with Emacs, but he starts typing and things are happening and I don't know what is going on. Also, that happens when other people watch me use VI, so even though I'm bad at it. Okay, so that was my little sub thing. All right, back to the main line of this story. So should we rewrite Juju in Go? Well, we could keep it in Python. Like, we had written 20,000 lines of code in Python. It is no fun to throw that away. Also, Juju does a lot of things with Amazon EC2 and OpenStack and a bunch of things where there are API clients already written in Python. It used YAML, where there's already a Python library. Basically for anything you want to do. Because Python is a mature language, and there's a library for this. We had a pretty large code base with really good tests. We at Canonical have a lot of really smart Python programmers. A huge number, actually. Well, huge. Like maybe a couple hundred. Like a number that's real. And people with core, like Python core developers and whatnot. We have a lot of investment in Python. And at this point in the world, there are a lot of Python programmers that exist. You can find them on the interwebs. On the other hand, there are a lot of Python programmers. Who knows Theodore Sturgeon? Nobody. Okay, Theodore Sturgeon was a science fiction writer. And I'm not going to read this whole thing, because you all can read faster than I can talk. But people call this thing Sturgeon's Law, and they say that 90% of everything is shit. That is Sturgeon's Law. He calls it his revelation, and it happened that he was reading, or talking to a bunch, he wrote science fiction, and quite good science fiction, I believe. But he would always talk to people and they'd be like, oh, I read some science fiction, it was terrible. He's like, yeah, I read some fantasy novels, I read some romance novels, I read some modern literary fiction. 90% of that is all terrible too. Like, you shouldn't blame science fiction because it is equally shitty to everything else. The reason this is important is there's a lot of Python programmers, but there are a lot more shitty Python programmers than there used to be. So there's a lot of them, but they're not all good. The cons were, there are more cons than this, and I will talk to a couple of points that I missed. 20,000 lines of code is a pro in that it's already written, but it's a con in which almost every single line of that code is a callback for something. That is really hard to trace through when something bad happens. You're like, what? You get call stacks that are almost as bad as if you were using TurboViews, which is the web framework that I wrote, which had horrible stack traces. It had stack traces that were so deep and horrible that we wrote a tool that would fix your stack trace before it showed it to you. We're like, we're gonna hide all this crappy junk. It didn't happen there, it happened in your code, which is true. But it was terrible. Other cons, Python is a bunch of files on disk. When you want to upgrade from one version of Juju to the next, you have a client on your laptop where you're typing Juju deploy WordPress. You have a state server that keeps track of what you want deployed where and how much of it and all of those things. And then you have agents on every single machine that says, oh, this is what you ought to do. When I want to upgrade, it is a pain when you want to upgrade and you have a bunch of libraries that you depend on, and those libraries, because we use a lot of Python at Canonical, may also be used by other things in your Ubuntu OS. So you can't just upgrade them. So we have to like set up virtual environments and and isolate our Python from everybody else's and our libraries from everybody else, and it's a pain. And the distro people don't like it because then there's 2 copies of that same library, and there's sadness. There's wailing and gnashing of teeth when we want to upgrade Juju. And also, we were actually running into some performance bottlenecks that were CPU related. Honestly, those things could be fixed by just fixing our Python. But what if we did a rewrite? Well, we get some pros, we get some native and easy to use concurrency primitives. The most important thing here, as a Python person, is that there's this thing called the Zen of Python. It was, if you go into a Python prompt and you type import this, it will list out a little thing that is like, will help you understand Python and how to write good Python. And it has many things in it. One of those things is there should be one, and preferably only one, obvious right way to do it. With concurrency, Python does not do that. There is twisted, there's greenlets, there's threads, there's multiprocessing, there's more. And Guido has a new one. Tulip. Philip Ebby had one. There's just a million. There's a million different ways to do this. And so every time you look at somebody else's code, they did it differently than you would. Whereas Go, you use Go routines, you use chains. That's what you do. Everyone does it. It's relatively easy to understand and reason about. And most of your stuff is still being executed in order. I mean, you can still mutate data structures in the background that Go routines depend on, and that will cause you bugs. It has some tools for helping you not do that, but that is the thing about concurrency you have to do. And Go doesn't solve this problem. It's not magic. Some people claim to have the magic language that fixes everything. It also runs really fast. It's faster than Python. And it gives us a single binary that is Juju. There's no like whole bunch of libraries. This is actually, it just doesn't implement dynamic linking. So you don't have an option. Everything gets compiled in. Which is bad because distro people hate it, because what if there's a security bug in the Go crypto library? That means you have to recompile everything. Whereas if it was dynamically linked, you wouldn't. You just replace the Go crypto library or the C crypto library, and you're fine, theoretically. Theory is great in theory. But for us, it's amazing because we can just replace a binary. Be like, hey, here's the new Juju agent binary, use it now. And if it doesn't work, we can go back to the old binary. We don't have to delete it, we just call it a different one. All kinds of things are nice. We also decided that we wanted to have a competency in Go because Go is great for lots of problems that Python is not as great for. And we were using C++ and C for those problems. Go, I cannot believe I have not mentioned this up to this point. Go is a memory managed language. You don't have to do all your own pointer arithmetic in Go. That eliminates the largest, by far, like an order of magnitude larger than any other cause of security issues in our distro, but in any OS, is somebody has a buffer overrun. That's just like everything you see, every security issue, like Heartbleed, pointer arithmetic was done. That's just the way it is. So we wanted to have a Go competency. This seemed like a good use case. Truth in advertising, I started right as this discussion about whether to rewrite in Go was being wrapped up. So I knew that there was a very high likelihood when I signed the paperwork that it would get rewritten in Go, but I didn't know for sure. But by the time I actually started, it was decided. So I didn't make this decision, but I know the logic. Another con is we had to write our own YAML parser. which is config file parser. We had to write our own MongoDB driver. We had to write our own libraries for Amazon Web Services. We had to write our own libraries to talk to OpenStack. We had a lot of libraries to write. And there aren't that many Go developers out there in the world. The corollary to this is that the people who learned Go 2 years ago were pretty much smart people. So if you found someone who knew Go, the chances that they were crap were less than if you found someone who knew Python. Which is not the most useful heuristic, because you can also figure out if somebody is crap. But it was kind of nice. You'd be like, hey, I've been writing Go. Probably a good program. Because they're the kind of person who wants to learn Go. Which most programmers don't crack a book. They don't learn a new thing. They don't go to a user group. They don't do anything to get better. They just write some Java code that they learned in college 20 years ago. Yeah, I guess you can have learned Java 20 years ago. Man, I'm old.
We don't even agree.
So, we did in fact decide to rewrite it in Go. And I think it was a really good decision. For many of the reasons we already talked about: single statically typed binary, or statically linked binary. Statically typed binary, I don't know what that means. But we learned a bunch of things. The good news is I have never met anyone who had any trouble learning Go. Because Go is boring. It doesn't let you do any interesting, crazy things. Python lets you do interesting, crazy things. There's like under slots, under, which changes the way that object attributes are managed by the interpreter. Like, that's some crazy shit. You can do it in Python. There's no similar craziness in Go. There's no meta-class hackery in Go. There's no
classes.
classes, really. There's
The structs.
class-like things. Struct things that are a little more classy than other structs.
Object-oriented?
Yes and
Yeah.
no. There's objects, but there's not classes. So it's not quite object-oriented in the way that it's not class hierarchies. There's no class hierarchies. So if that's what you think when you think object-oriented, which is what most people think, then it's not that.
But there's interfaces.
But there's interfaces and there's structs and there's things that are objects. They just don't inherit from some class. They implement an interface, or they are a struct. And structs can have methods, so that is like, it's kind of like an object that you would think of. But it's really easy because there's nothing complicated in Go anywhere. Like, the two hardest things to understand about Go are Go routines and channels. And those things are not hard. Like, Go is great because it is super boring. And you can't do anything interesting. Which means when I read Go code, I know what the hell it is doing. Whereas when I read Ruby code, who knows what is going on. But we had some problems with Go because we took a bunch of people who knew Python and we made them use Go.
Are you going to use Go in the same way you would use Ruby as a server script?
So we use Go for all kinds of server-side stuff, yes. Like, we have a single executable binary that lives on the server that implements a HTTP interface, and we make API calls to it from other things that are Go on other machines. So we use it like, I mean, it's a general purpose programming language. We have Go QML bindings, so you can write web app, or not web apps, you can write 3D GUI apps for your phone, your Ubuntu phone, which you'll be able to buy sometime in the fall for a lot of money. It will not be cheap. We're not selling it, but other people are. I lost my train of thought here. What was the question? Oh, servers. Yeah, so we use it mostly for server side. It was developed.
Something like Ruby or PHP or,
Right, it was developed by Google for server-side programming. They did not really envision it being used in client libraries when they first developed it. It was an alternative. So in Google, they had Python, Java, and C were their three official languages. Some other things happened, but those were the three that were official. And they each have very specific and useful use cases. Like Python is fast to write, it's easy to get a lot of things done, but in terms of execution performance is nowhere near as good as Java or C for the same algorithm. You can, if you write a better algorithm, you can get faster Python. And the company that I mentioned at the beginning where we did the network queue and whatever, MedX was originally written in Python. We rewrote it, or it was originally written in Java. We rewrote it in Python, and it was somewhere between 10 and 50 times faster. Not because Python is faster, but because we did it differently. Mainly because we used SQL in the same way, but that is a whole story for a different day.
can I use it to access SQL? Go?
Yes. There are established patterns for that. It does not have something like, Python has this thing called SQL Alchemy, which is like SQL magic, thus the name. And it is amazing. Amazing. Go has nothing quite as amazing as that. But, I mean, if you just want to write SQL and make queries and use the results, Go will let you do that. No problem. The situation has changed a lot in the 2 years since I started at Canonical, and we started rewriting Juju into Go. First of all, Juju is now by far the largest open source project in Go that I'm aware of. We have a couple 100,000 lines of Go at this point. So it is a non-trivial piece of code. And there's a bunch of non-trivial work that went into figuring out how to make a project of that size in Go, because I'm not aware of anything else that is that big. Like, Google uses Go for a lot of things, but those things are relatively small. We are big. Things that were particularly problematic when we switched to Go. The most important of them is testing. The Python developers were like, oh, I can just mock this thing out by replacing it. No, you can't do that. You can't change the meaning of things dynamically, because it's not that kind of language. And so there are patterns like dependency injection, where you're like, I'm going to call a file handler, and I want to have a mock file handler for testing purposes. The only way to make sure that you can test it easily is to pass in a reference to the file handler that you want to use in the function, so that you can pass in a different one when you're testing it, which is not the way Perl or Python or Ruby programmers think. It is the way Java programmers think, but we didn't have very many of those, so it took us a little while. The other thing about Go that surprises some people is there are no exceptions in the classical sense. Like, Python uses exceptions for all kinds of things. Like, there's a stop iteration exception. You raise stop iteration when you want to stop iterating over a thing. And something catches it and says, oh, that means you're done. Go does not have that. It does not have a standard error object or exception handling library. If you want to do that, you have to pass an error back in the return of the function. You have to define the error.
Feels like we're going back to C, doesn't it?
It is kind of, so this is a thing many people have this reaction, a sort of visceral negative reaction to.
So I'm not alone.
No, you are like every person who worked on Juju, who came from Python. There are advantages and disadvantages. What we ended up doing is writing a library that manages errors for us. So we have an error struct and an error object, and we have a specific way of handling errors, and we use that. And we do, the good thing about it is like in Python or Java or whatever, you have an exception that gets thrown somewhere, and oftentimes it bubbles up and bubbles up and bubbles up, and then somebody catches it inadvertently and does something stupid. You can't really do that in Go. Like, unless you just call everything error type and then pass errors up, and you have to think about where the boundaries of where can I handle this error and where I can I not. And it does have panics, which have stack traces and whatnot, but a panic is a panic. It is not a thing that is meant to be handled. It is a thing that
You're
is
done.
holy crap,
Jumps core and-
bad
Yeah,
thing
you're done.
happens.
So, are these things missing, like classes and exceptions and stuff, because it's a design decision, or because they just haven't evolved?
It is a design
Design
decision.
decision, really.
They want you to think about where the boundary for handling this error is.
And Rob Mike hates exceptions.
Yeah, Rob Pike. Some of this is Rob Pike.
It just seems like they made it really easy for the compiler writer, but not so easy for the programmer.
So, I mean, we wrote a library that makes this a lot better. GitHub.com/Juju, there's a whole list of things that we did, and our error library is there. It is not Juju specific, but it's from us, so that's where we put it.
So you're putting all your the things that you're writing up there on GitHub.
We are now. We used to put all our things in Launchpad because we're canonical.
Yeah.
But we're putting things on GitHub.
But they're out there.
Because we've evolved.
Fast compile was one of his objectives when he wrote, when he started it, because he wanted
Oh, it
continuous
compiles
build.
really
He
fast.
wanted it to be really, really fast to
We
compile,
see, because
so.
the compiler doesn't have to do that much.
Right.
But the beauty of it is, I can compile and run my tests as fast as I can run my tests in Python. Like, I don't ever have this, oh, I'm gonna wait for a while for it to compile so I can run some tests. Like, we have a huge code base, and it still compiles really, really fast. Assertions are special too, in that they don't exist. If you wanna assert something, you gotta write that then. Our test library, we have a bunch of assertions, because it's fairly useful to be able to assert, like, slice not equal, things like that. Things that are not specifically testing related, there's no such thing as generics. That may or may not change. That is not like errors, where errors are going to be, errors are the responsibility of the programmer for design decision reasons. Generics are not there because they didn't seem reasonable to implement, and they may someday be there, but there's no guarantee. It's like dynamic linking. Rob Pike is anti-dynamic linking, but he would not reject a sane implementation of dynamic linking. That's what they told me in Gopher, which made us very happy, because as a distro, the people who run the distro really, really want to be able to, if there's a security problem in the Go crypto library, not recompile every Go program. Which is not really an issue about compilation time and difficulty. It's about, we have a huge amount of infrastructure that would have to be built to know what everything needs to be recompiled and then push that all out. And then there's some bandwidth issues. But actual compile time is really fast, so it doesn't matter. And then, what time is it?
5 after 8.
Okay.
20, 25 minutes.
So Go also has a philosophy that is very fit with its origins at Google. Go 1.0 came out, and you should use 1.0. Go 1.1 comes out, you should use 1.1. If there's a security problem in 1.0, you should upgrade. We don't want to backport it. We, as a distro that wants to have a 5-year long-term stable release, that is a struggle for us, because a lot of things are going to change between the Go that came out in Trusty 2 months ago and the Go that will be the most modern version of Go 4.5 years from now. And it is not reasonable to assume that everybody's code will just work and nothing will break if we change Go versions out from under them. The Go community and Rob Pike and all the devs of Go would like to never break backwards compatibility. And they are pretty good at it. They have not broken us in a stable release. We have, because we were one of the largest Go projects, we compile against TIP all the time, and we have been the people who found garbage collection bugs and whatnot. So we live on the bleeding edge, and we don't have a lot of choices unless we want to backport security fixes ourselves, which we will do. That is our plan going forward.
Mm-hmm.
And we have people who maintain compilers and who backport things, and we're a distro. That's what we do, so we're gonna do it, whether Upstream does it or not. But we're also hoping that Upstream understands the needs of distributions, and especially as Go evolves from a server-side only application-specific language to a language in which people are writing things that get reused in desktop distributions and server distributions that get, where it's not, you're running this server for this application, which is what Google does. You're running a mail server and it just happens to be written in Go. It is a different world, and we have to think differently. And the community's been pretty good about working with us. So here's kind of a summary about things we love about Go. It's really good at a lot of things. I think Brian Fitzpatrick, who's a Google employee, but a very, I just was about to say, he's a Google employee, but a very smart guy. As though most Google employees are dumb, which is not true. He is a very smart guy who is a Google employee, and he says Go is 90% perfect 100% of the time. I don't exactly know what that means, but it sounds about right.
Critically low.
Uh-oh.
AC core.
You can write high-level code when you want. You can write some low-level code. You can do threads. You can go to C, and going to C is not expensive like it often is in dynamic languages. And it's statically typed, but you don't have to declare what type everything is all over the place. It infers that, so you don't have a bunch of, like if you've written Java and then you write Go, you'll notice that you just write a lot less code.
They came disconnected.
Yeah. All right, and we're almost done.
Everybody happy?
So somebody asked about writing a server in Go. So this says, you know, you have a connection, we're going to accept the connection, and then we're going to serve this in a Go routine. And so each connection gets handled by the Go routine. That's like if you want to actually turn your thing that responds to connections and does stuff into a server, it is not, there's no rocket science to this. This is very simple.
So there's a function you created called serve someplace
Yes,
else? Okay.
and there's a function called accept. And, I mean, so this is not your whole program. This is the part that listens for,
Okay.
but this scales like crazy too.
Sure.
If you have an 8-core machine and you don't set Go max procs to 1, which we did for a long time, this will just scale, and it just does it, and it's awesome and magical and cool, and it really actually does work, unlike some other things which promise the world and deliver my head exploding. Oh, and here's the 90% perfect, 100% of the time quote. So, in the end, like, it costs us a lot to rewrite Juju and Go. It took probably a year to get up to the same point that the Python Juju was. But since then, we have done a ton of things that would have been incredibly difficult to do in Python. It scales really well. We've had, like, things just scale way better and more easily for us now than they did in Python. Particularly in Python, we had a lot of a lot of our scale problems were YAML parsing. And YAML parsing, super fast in Go, so that has never been an issue, and we have hit, our scale problems are now with our MongoDB database, not with our Go code. Some with the way our Go code uses MongoDB, but you know, that's the way it always is when you have database scaling issues. And we have the single statically linked binary, which makes our upgrade story so much easier. And I think it's a net win. And I come from this as a Pythonista, as someone who spent most of my life in Python. I wrote a book about Python development. I wrote a Python web framework. I was a Python person. My most popular blog post of all time was why Python is better than Ruby. Which is just popular because I was being a jerk. Although I was kind of nice about it. But I pointed out some things. And I reread that blog post recently and I was like, man, that stuff is still true. It has been 5 years. Same crap. On both sides. And like 5 years ago, I thought the global interpreter lock had a limited expiration date. Now I think the global interpreter lock is a part of Python until the end of time. Or until PyPy takes over, which also is the end of time. Only the Python people are laughing, because nobody else knows what that is. That they re-implemented Python in Python.
It is so fast.
Unless it's not. It is amazing in that it is super fast a lot of the time, and occasionally really slow. But it is amazing that they made Python, written in Python, with an interpreter written in Python, faster than Python written in C.
Wow.
For a lot of cases. It was amazing. When they first wrote PyPy, it was 100 times slower, and they're like, yeah, that's not a problem. And then it was like 50 times slower, and we're like, well, okay. Then it was like 20 times slower. Then it was 10 times slower. Then it was 3 times slower. And then it was just as fast. And then it was twice as fast. And you're like, what are you doing? How do you do these things?
I don't know when to stop.
Yeah, when it's 100 times as fast.
Yeah.
No. I mean, it does a lot of just-in-time optimization stuff that the C version can't do because it's too hard to write C. Which is another reason maybe somebody should write Python and Go.
So they call PyGo, huh?
Haha, someone will
Pygo.
do that.
Or GoPy.
Go
Yeah, well,
Py.
there's
Go Py.
Python, and IronPython was Python rewritten in C#, and PyPy, Python in Python. So, I mean, it's probably inevitable, but I'm not going to do it. 2 reasons. 1, I'm too stupid, and 2, I have no time. So that's my presentation. Are there questions?
So are you looking to start more projects in Go at Canonical?
Yes. We have done a lot of things in Go that are not Juju. There are things for the phone that are written in Go. So we'll be running Go on people's phones, we'll be running Go on people's servers, we'll be running Go on people's desktops. We are expanding our use of Go significantly.
So it's a general purpose programming language.
It is.
It's suitable.
It is suitable.
In fact, anything that you might have written with C++, you might write better with Go.
That is largely true. Well, honestly, you just shouldn't use C++. You should use Go. Like, there are plenty of times when you should use something other than Go, but that something should not be C++. But that is me being an opinionated bastard, but also correct.
So is that though because most of the Go program is defined these days because there are some people going and they've not been writing Go for a long time, that you're getting better code quality period, and if they were applying that same skill set to another language, they would be producing likewise high quality results?
I think that is part of it. I think the people who write Go today are better on average than the people who write Perl today, or Python, or Ruby. Just because those are the people who go out and learn new languages and try to do new things and experiment and. it
Well,
is-
there's not a lot of corporations handing down Go as the
Right.
official language.
Right. They
You
didn't
must
learn-
this, yeah.
They didn't learn it in college because it was required and do it at work because that's what everyone does.
Right.
They chose it. That self-selection process means they're probably on average better. There are bad Go programmers, we've met them.
Choose languages in general, likely be better.
Right, if you choose something, like if you write small talk today, you're probably better than because it's obscure and weird.
Sure.
You're either better or you're an 8-year-old. I'm not sure.
And you said using Go on a mobile platform, are you talking as like a server script to a
No, we
to a
run
web
Go,
front end?
We run Go on the phone. So Ubuntu Canonical is an operating system company. I work on Juju, which is a service orchestration platform that's written in Go. But we write Ubuntu, the operating system. There are things in Ubuntu called scopes. Some of those scopes are written in Go now. And so those will be on the phone, on the desktop, wherever scopes run. I'm not sure if any of that has actually landed, but scopes have been written in Go. Whether I don't think they're in Trusty yet, but especially for the phone.
So you would compile an APK for my Android, you're saying?
For the Ubuntu phone, not for Android. So we have our own phone OS that will compete with Android and iOS coming out in the fall. Yes, that is a whole set of questions that probably had a different talk at a different time, but I will answer them at dinner. But phone, I don't know too much about.
Do you think that Go is a good, and I think you sort of already said this, is a good general purpose, good for almost anything type language?
I think it's 90% perfect, 100% of the time.
And
But what I mean by that is, I think there are times, for instance, Go is not your best programming language in real-time applications because it has a garbage collector that fires at random times. So depending on what your real-time requirements are, the garbage collector can screw. In the same way, Python and Java and any garbage collected language can be problematic with really strict real-time requirements. Go is not great. So I say that, but they wrote, you know those little quadcopter things?
Mm-hmm.
There's a quadcopter control system that is written in Go. And because the Go garbage collector is really fast, the real-time window is like, for that you probably need less than 100 milliseconds, and Go is fine for that, if you're careful. You could be uncareful and it would be bad. But it works. I mean, they don't crash all the time. And Go is not the most memory efficient language. So there are certain things on the phone that you would not want to write in Go. Those are still C. And there are some crypto things where you want, for speed, you need to use pointer arithmetic and do some crazy junk. That is, again, like Google recently came out with a library called Macaroons. It's like cookies on steroids if you do web programming. They're amazing. But there's a bunch of HMAC signing stuff and elliptical key cryptography stuff that is just faster in C and always will be because it does magic things with pointers that Go can't do. That said, Go is really fast at crypto. When people use Go for crypto, people use Go for server-side stuff, people use Go for client-side stuff, people use Go for embedded systems, people use Go for almost anything that you can think of. There's someone who's writing Go for that. But it lives mostly in the server today.
So you run the compiler and it spits out a binary file.
Mm-hmm.
Fully linked. Is it just a executable?
It's just
You
an
take
executable.
that, deploy it to another server somewhere and run it. It doesn't need.
Yep.
So
Now-
for deployment purposes, other than the size,
Oh, it's
you don't have DLL hell.
no DLL hell. But
Is this
recompile.
going into is there a runtime for Go that actually?
No, it's all in the binary.
So it is native binary, Intel code, or so you'd have to do a different compile
So-
for a different environment?
Yes, there's two answers to your question. He says no, there's just a binary, and
I
I'm
mean, the
saying
runtime is in there.
there is. It's in the binary that you create, but there's no separate runtime. You get an executable, that's it.
But that
And-
executable is gonna be specific to.
To that architecture.
To that
General
architecture.
purpose, yeah.
Yeah, and it's going to be specific to that platform. Like you're going to have different executable for OS 10
Because
versus
they're going to be doing system calls.
Right. Yeah. So it's platform and architecture specific. ARM32 is well supported. Intel, AMD 64 stuff is well supported. If you're doing things like Little Endian Power, which I can't imagine anyone in this room is doing, or ARM64, those are platforms that are not well supported with Go. And ARM64 is becoming widespread
It's just
because
because it hasn't gotten there yet.
right. So we're working on a relationship with a contractor who will do that for us because we want it. Because a lot of phones, there are some phones that are on 64 now. 2 years from now, every phone that is not an Apple phone will be ARM64.
Really? 64-bit, right?
64
On your phone.
There you go.
There
That's what
are
we need.
quad-core 64-bit phone processors
Oh, my
coming.
God.
Like, this is a terrible movie, but I saw the movie Iron Sky. Anybody see this movie? It's amazingly bad. Nazis on the dark side of the moon.
Oh, yeah.
But this dude lands on the dark side of the moon, and the Nazis get a hold of his phone. They're like, holy crap, that's not a computer. That's a computer. And they got the big tape reel. And I'm like,
So,
no,
part
that
of that was
computer,
that there
this
were-
little computer,
there were Nazis from the
thousands
40s,
and
right?
thousands of times, like 4 or 5 orders of magnitude more powerful than my phone is orders and orders of magnitude more powerful than the giant computer they built underneath Cheyenne Mountain for the North American Air Defense that was the size of a football field. And my phone kicks that thing's ass. We've come a long way.
And takes pictures.
It does.
Yeah.
It has a camera.
And movies, yeah.
The one thing that it does not do better than that other computer is survive a direct nuclear hit. I can't even drop it on the floor.
Yeah.
So there's a little bit of dirt.
Oh, and kind
You get a direct nuclear hit, your phone survives the least of your.
Well, hopefully I left my phone far, far away. That's what I try to do is convince people to drop nuclear bombs on my phone while I'm gone. That's why I travel so much. I leave my phone here so you guys get blown up. Okay, that was so far afield. Other questions? Nope.
Great, thank you, Mark.